Bonjour à tous. Après sa venue ici, j'ai en France que j'ai appris quelques français, mais je suis désolé parce que je ne parle pas bien le français, mais je voudrais faire la présentation en anglais, s'il vous plaît. Our work is about word sense disambiguation, how to rapidly create a supervised word sense disambiguation system for under-resourced languages. In my talk, first I will discuss about the word sense, the objective of our work, and our contributions, that how we contributed in this work. And then I will discuss about the word sense disambiguation, and the characterization of different languages, and machine translation, specifically statistical machine translation. Then I will talk about, I will present our work, that how we were translating the sense, one sense annotated corpus from one language to another language, and transferring the sense annotation from one language to another. Then we will talk about the results. We'll show our results and compare our results with different state-of-the-art word sense disambiguation systems. And finally, I will conclude my talk and show some future perspectives. The objective of our work is to quickly create a word sense disambiguation system for under-resourced languages. But we have two conditions. First one is that we have to make sure that we have a sense annotated corpus for a well-resourced languages, and a statistical machine translation is available to translate from a well-resourced language to the under-resourced languages. And our contribution is threefold. First one is the script. We would like to provide our scripts for the community, which will help them to translate a sense annotated corpus and create the supervised word sense disambiguation system for any languages. Then we already translated SemCor into Bengali and into French, and we also would like to provide it for the for our community. And in the third step, we are due to lack of sense evaluation corpus for the Bengali language, we took the French evaluation corpus from the Semeval 2013 task 12 multilingual word sense disambiguation task, and we would like to evaluate our hypothesis whether it's really improve the performance or not. So let's understand what is word sense disambiguation. Word sense disambiguation is the process where we automatically identify the sense of a word from its context. So it's we know that it's a kind of fundamental problems in natural language processing and its applications. And if we take the simple example of the mouse is eating cheese in this small context, the three ambiguous words, the word senses has been collected from the Princeton WordNet 3.0, where we have different senses from animal, for the word mouse, animal to electronic device, and for the word eat, which can be used to the consume, and for cheese to food to get away. So finally, we would like to get the sense annotated corpus, something like this, the mouse as an animal and is eating as a swallow, and cheese as a food. So from this example, we can see that if we think the words as a set of words, then we would like to, we can say that, okay, we would like to map the senses from set of senses to the words. And for our simple understanding, we need the sense inventories. So in this case, we had to linguistic resources. Most of the cases, the linguistic resources has to be adapted to the word sense disambiguation system, and in the second step, would like to give the unannotated corpus, which will be used by the system, and finally it will give us the sense annotated corpus. So now see that what are the linguistic resources has been still now exploited for word sense disambiguation. So in our basic understanding, there are two sort of resources has been still now exploited for word sense disambiguation. One is the corpus, another is the sense inventory. For the corpus, which can be ranged from the unannotated corpus like brown corpus, and for the sense annotated corpus, it's a sense text corpus. Like in our case, we used the SemCor, which is the sense annotated corpus of brown corpus, which was annotated, and those senses, those words of these senses has been annotated from the Princeton WordNet 3.0 for the version SemCor 3.0. And this is the freely available corpus still now. And we have another example is the DSO corpus, which is not freely available. You have to buy it. And for the sense inventory, which can be seen as that some sense inventories are more elaborated and some are less elaborated. For the less elaborated sense inventories like calling English dictionary, and more elaborated like WordNet, BubbleNet that we already know about, and the divinary, which has been built in our lab. So for the supervised word sense disambiguation, we can see the supervised word sense disambiguation as a probabilistic view. If we consider that a context with the bunch of words, then for a target word W, our disambiguation, our classifier or the disambiguation algorithm should give the most probable sense for the target word W. So in this case, we can say that it happens within two steps. One is the training step, and another is the classification or the decision step. So in the training step, where we have to collect the different feature sets from the sense annotated corpus, then we had to feed it to the classifiers, then we will train our classifiers, and finally, for the classification, we will give the unannotated text, and from these training data sets, our algorithm will make the decision, and finally, it will give the output as a sense annotated corpus. So now let's understand that what are the under-resourced languages. From Vincent Barmo in 2004, he classified languages into three categories depending on the digitalization of data into the computer till their applications in different languages. So he classified the languages into three parts. One is the PI languages, which is, we would like to call them also people known as the under-resourced languages. Most of the languages are lies in these categories, and like Bengali, Somali, Ivan, and a lot of other languages exist in the PI languages, depending on the score 20. And for the Mu languages, some are languages which are in the medium level, which is very medium level resources, linguistic resources like Norwegian, Malaysia, and so on. And for the Thai languages, Tau languages, very few languages enjoy these sort of resources like English, French, and so on. After 11 years of this classification and considering the word sense disambiguation and machine translation, we would like to consider that Bangla is still now under-resourced language. Now let's talk about the machine translation. So machine translation is a process where it helps to translate one text from the target language to the source language. And statistical machine translation is a data-driven probabilistic statistical approach which helps us to do this translation. Where this can be computed by the argmax computation. So in this case, a decoder which contains of several models like the translation model or the language model and so on, which help us to maximize the probability of the translation in the target language. Now, in our work, we used two machine translation systems. One is for English to French, another is the English to Bengali. So in the English to French system, this system participated in ISWLT campaign for the speech-to-speech translation, and in the ranking, our system stood 7th, and the blue score is 24.85. For the English to Bengali system, we took a lot of resources which is freely available from the web, and we also collected the parallel corpus from the different comparable corpora. Then we trained the system, and we achieved the blue score 27.21. So now people can ask that, okay, what is the good blue score, or what is the good translation system for translating the one sense annotated corpus into another? So this is another sort of questions, but in this case, we don't want to justify the quality of translations, but our main goal is to use it for the supervised system. So now let's see what are the state of the art. Some of the state of the arts works which has been used for transferring the sense, transferring the annotations for in different NLP applications, like Brown et al. In 1991, they used the annotation transfer for WSD to transfer from English to French, and Eurosco and Nagai in 2001, they used for the part of speech tagging, and Eurosco and et al. In 2001, they used for chunking and so on. And to the best of our knowledge, recently Wang and Manning in 2013, they used the sense, the annotation transfer for English to French in the semantic role leveling task. So now let's see our algorithm. So to do our to translate the sense annotated corpus, in our case the SemCor, we took all the sentences from the SemCor, then we feed it to the SMT system, the Moses, and we got the corresponding translations into the target language. Then we had also the word-to-word translations, where in the HTML structure of our SemCor, we just replaced the translated version of target word with the source word. So this is the example of SemCor, where in the left-hand side of our SemCor, which is the original SemCor, and in the right side is the translated SemCor in Bengali. So you can we can see that here the word "da" is translated as "r" in Bengali, but the Fulton country grand jury, which could not be translated because this our system does not know that how to translate this multi-word expression. Then we had Said has been translated as Bolechilen, and so on. But the sense which was already present from the WordNet 3.0, we did not we transferred the senses from this language from SemCor to the Bengali SemCor. And if you look that you can notice that we did not translate the lemma form. We just put the original lemma form from the SemCor to the Bengali SemCor, because we did not find any morphological analyzers for Bengali, but we did it for the French. So we used the naive bias classifier for our experiment, where the Bayesian classifier, which makes the decision from the for a word from its previous trained data to find out the almost closely related sense from a set of senses. So in this case, as we also know that in naive bias classifier, the attributes in instances are independent of each other, and which can be computed as the arithmetic computation. So these are the feature sets that we have used in our experiments, which has been taken from the NUSPT system, which participated in Semeval 2007 task 7 coarse grained word sense disambiguation task. Here they took the three types of feature sets. One is the local feature, which has the 11 features, and for part of its feature sets, which has the 7 features. So here is an example like the Fulton County Grand Jury said Friday an investigation of Atlanta's recent primary election produced, and so on. So here in this case, we can see that for the post-tag data, which is -3 to that means the left-hand side of our target word is the Friday. So from -3 to +3, so we took 7 words, and for the all words, we took all the words from our target words, and for the local collocations is the Fulton Grand Jury for the C1 -1 to -3, and so on. So from these data sets and from this naive-Bayes classifier, we built 3 systems. One is for English, which is trained on the original SemCor data, and another is the Bengali, which is trained on the translated version of SemCor into Bengali, and another one is for French, which is the French version of SemCor. So as we mentioned previously, due to lack of gold standard data or the evaluation data for Bengali, we took the French SemCor as our evaluation purposes. In this case, we used the evaluation corpus from the Semeval 2013 Multilingual WSD task 12. So in this case, which task for the evaluation is given in 5 different languages. So in this case, we used the English and French corpus, and each corpus consists of 13 articles from different domains, and all the words we had to disambiguate are the nouns. But we had some challenges when we were mapping the senses from the SemCor to the WordNet 3.0 to the BubbleNet senses of 1.1.0. So we had around 3.9% missing senses. So for the evaluation, we also took the classical evaluation measures like precision, recall, and F1 score. In the precision, which computes the number of correct senses divided by the number of senses given by the system, and in the recall, which calculates the number of correct senses divided by the number of senses should be given by the system, and the recall and the F1 score. F1 score is the harmonic mean of recall and precision. So now let's see what are our results. So in our results, we can see that for the 2 systems that we have shown, that for the SemCor, which has been trained on the original SemCor, we had the most frequent sense baseline. Most frequent sense baseline is the baseline, which is somewhat, it is well known to the WSD community. It is somewhat tougher to, difficult to beat this system. So how this most frequent sense baseline, has been calculated? It calculates that from the for a word from the bunch of senses, it calculates that which one is the most frequent sense from this word. So it takes this word into our system. So in our baseline, we can see that for English, we could not beat, our system could not beat the our baseline. But it's interesting to know that for French, our system beat the most frequent sense baseline, which is 0.621% more than our baseline. So if we would like to compare our results with different systems that has been participated in Semeval 2013, we could say that if we could participate in Semeval 2013 task 12 multilingual WSD task, for two systems, maybe our system could win the, for the English, it could win the second position, and for the French, it could win the third position. Like the best system for this task, which was the UMCC DLSI system, which is unsupervised system to the best of my knowledge. Most of the systems were unsupervised, and our system was the supervised. And we also participated in 2013 with our unsupervised system, which was, I mean, not that up to date, I mean, up to the performance, so which is like 58.3% F1 score. And the French, which our previous system, which is 48.3% F1 score. But in our ranking, we can see that our supervised system that we built from the translated SemCor and with the transferred senses, which is 51.55 for the French. So we can see that we could easily get the third position in the system, in the task competition. So this is our results, and finally, we would like to conclude my presentation by saying that here in this presentation, we presented how to rapidly create a word sense disambiguation system for any languages, especially for under-resourced languages, and how to translate a sense annotated corpus into our target languages, and how to transfer the sense annotations, and how to build a supervised system easily from this task. And we also shown that by using very little data and without any sort of parameters, like by using the naive system like the naive bias, we could easily get the state-of-the-art performance. And in perspectives, we already have bought the DS corpus, so we would like to see by putting more data whether whether really it improves the performance or not. And we also like to do the experiment with different classifiers like SBM and others classifiers. Then we can also check different boosting algorithms by different fusion techniques. And we are also working on to merge the supervised and unsupervised approaches and see the performance. So thank you very much. This is our scripts and slides and all the resources can be found in our website.
So I have a question, which is actually also a suggestion. So what could be done to further improve the performance? I think it's fine. To further improve the performance of your approach. For example, would it make sense to, because one of the problems would be that maybe in the translation you choose the wrong word, okay? So could you, for example, double check in BabelNet or some other way whether that's a translation of that meaning, the original meaning that is provided in SemCor? Because in SemCor you know, right, what is the meaning of the English word. So maybe you could further check that the translation is correct at the semantic level because you know the meaning of the original word, and maybe manually post-process those items, which will not be so many, maybe. I don't know, or other suggestions you have?
Yes. I mean, thank you very much. It's really a nice suggestion, because we are also, we had also computed that, okay, how many words, it translated correctly, but we did not have enough time when we are making the experiments to calculate that, okay, how many words really it translated correctly, because it's really is one of the important thing. Suppose here in this case, we sometimes, our system could not translate some words, so just it gives the unknown words, or maybe it gives the original words, just we replaced it. Maybe this is one of the reasons which could increase the performance, but we don't know. Thank you very much.
In fact, in the performance on your supervised system in English, you say that the performance of the system is even worse than most frequent tense.
Yes.
So, did you have an explanation for that? Or?
Yes, because we were translating from English to the French. Okay, so.
Sorry, in the supervised English system.
Yes. Yes. Yeah. Yes, yes. In the supervised English system, yes, which is trained on the original SemCor.
Yes.
So in this case, which could not beat the sense our baseline, but in the French it could.
Yeah, but do you know why in English it cannot beat the most frequent sense baseline? Because normally I think
this is the question. This is the things that okay, we could not beat with the original SemCor, but it's a nice, interesting thing. That's why our paper has been accepted. That's why people, we are also, very much, happy that okay, why it, how the performance really increased in the translated SemCor. This is one of the real questions. Yeah. We're also looking for the answers.
Yeah, because in fact, I'm interested in why, because normally we have the most frequent sense, and I think a supervised system should beat the most frequent sense. I don't, okay, we don't talk about the French side, we talk only about the English side.
Yes.
I don't know why.
Yes. Yes. You're right. Yes. It should. This is one of the interesting things.
Yeah, it could be interesting if you did into that question because.
That's why and we also would like to see that how many words has been correctly translated or not. But SemCor is a huge, so we have millions of words, but it's too difficult to manually check all the words. Yes.
This began with work on Bengali, and what are the results of Bengali?
Still now, as I mentioned, that still now we could not get the gold standard data for Bengali, so we don't know. But that's why our evaluation for French. So we can probably say that we can translate the SemCor into French. Then maybe for Bengali we expect that it will also increase the performance. Maybe we are working.
This is not the same Bengali, so you have to correct the data.
Yes. I agree with you.
So maybe I can add to the question. So it's the question why the English supervised system doesn't beat the BMFS. I think here the reason is that you usually don't train on SemCor. You train on training data from the same corpus, okay, another part of the corpus, while SemCor has probably a different distribution over. So it's probably not as well. It's easier. It's better to train on the same data you test on.
Yeah, you mean maybe different domain or?
Yeah, exactly. Because those texts come from different domains.
So okay.
That would be the reason.
The training is on SemCor and the test is on the Semeval 2013.
But I'm also not. Happy with this answer. Why is that? Because dataset are, of course, from different domains, but this is all the same data set for French also, English. So it should be also decrease the performance for French, as my understanding.
Yes, it's true, but performance goes lower, so maybe, it goes lower, so it's noisier in general.
Yes. That might be one of the reasons. Please.
Perhaps there is a small kind of effect of translation on mapping a set of very diverse senses to a smaller set
Maybe.
of senses.
Yes, that might be.
And that could have an effect.
Maybe. We'll check it.